Today we discuss Maxwell equation in free space. So first we discuss general form of Maxwell equation. Maxwell equations. Number 1, grad dot d equal to rho free. Number 2, grad dot v equal to 0. 10 curl of E equal to minus del v del t. 4 curl of A is equal to jf plus jd. These are the 4 Maxwell equations in general form. Now, if we transform the Maxwell equation for free space, then for free space we put rho free equal to 0 and j free equal to 0. Then the Maxwell equation in free space or vacuum look like this. First one, divergence of D equal to 0. So number divergence of B equal to 0. Number 3, curl of E equal to minus del B del T. Number 4, curl of H equal to JD. Now we use Maxwell equation to form the wave equation. So now we develop wave equation. Wave equation by the use of Maxwell equation. So if we take curl of Maxwell third equation, then it will be curl of E equals to minus del T of curl of B. So we know curl of E equals to grad of curl E minus grad square E equal to minus del T of curl of V. And from the fourth Maxwell equation, we write curl of V equal to we know B equal to 0 H, or H equal to B by mu. So equal to mu, curl of B equal to mu 0 ZD. So I put here, then we get del T of mu 0 ZD. Divergence of D equal to 0. From this we write divergence of E equal to also 0. So this term will be 0. So we get grad square E equal to mu 0 del JD by del T. And again we know JD will be the displacement current density, which is equal to epsilon 0 del E by del T. So we get mu 0 epsilon 0 del E by del T. So, and again we know mu 0 epsilon 0 equal to 1 by c square. So putting this value, we get grad square E minus 1 by c square del E by del T equal to 0. This is the wave equation for electric field. And similarly, if we take curl of fourth Maxwell equation and derived, then we also get grad square B minus 1 by c square del V by del T equal to 0. So these two equations are the wave equation. Now we find the solution of these two equations. The solution will be, for electric field it will be E equal to E0 exponential I k dot r minus omega t. And for magnetic field, V equal to V0 exponential I k dot r minus omega t. So these two are the solution of the wave equation. Now we discuss the direction of EM wave. EM wave, which means in which direction the EM wave will be propagated. In the exponential term, k dot r and the omega t, these two terms sign are different, then propagation will be occur. And if the k dot r and omega t, these two terms sign are same, then this will go along minus r cap direction. Now we see the outcomes from the Maxwell equation in free space. Outcomes of EM waves propagating in free space. Propagating in free space. Now first Maxwell equation, we see grad dot E equals to 0. Now if we put the value of the E equals to E0 exponential I k dot r minus omega t, then we get k dot E equals to 0. Number 2, from the second Maxwell equation, grad dot B equal to 0, we get k dot V equal to 0. This too implies that the electric field must be perpendicular to magnetic field and also perpendicular to the propagation vector k. So these two outcomes implies that electric field, magnetic field and propagation wave vector will be mutually perpendicular to each other. Now From the third Maxwell equation, grad cross E equal to minus del V del T. From this equation we get A cross E equal to omega V. Putting the solution for E and V, we get these two. Then we finally get V equal to K cross E by K cross V by omega. These are the important formula for finding V. Now from fourth Maxwell equation, we know grad cross B equal to mu 0 JD is equal to mu 0 epsilon 0 del E del T. From this we get A cross B equal to 1 by C square into omega E minus, so which implies K cross B equal to C square into K cross V by omega. This is also the important formula which is to find the electric field from the magnetic field. Next we discuss the energy density. In electric field, average energy density will be 1 by 4 epsilon 0 E0 square. Average energy density in magnetic field will be also 1 by 4 E0 square by mu 0, and average energy density of electromagnetic wave will be half epsilon 0 E0 square, where E0 is the amplitude of the electric field and B0 is the amplitude of the magnetic field. Now the pointing vector, which is A equal to S equal to 1 by mu 0 E cross B. Pointing vector means the direction of the energy flow. Which direction the energy of the EMI flows is measured by the pointing vector. Now if we find the intensity, it will be the average of the pointing vector. Which is equal to the energy per unit area per unit time, or it is equal to power by area, which is equal to half C epsilon 0 E0 square, which is the most important formula. I equal to average of pointing vector equal to half C epsilon 0 E0 square. Now the power will be P will be integration of average pointing vector dot ds. Now we find momentum density. Small p, which is equal to half epsilon 0 E0 square by C. Next we find radiation phasor. Which is equal to, I am right as P dash equal to I by C for purely absorbing medium, absorbing medium and P dash equal to 2y by c for perfectly reflecting medium. Next, most important thing, we'll discuss wave impedance. Wave impedance, which is right as Z0 equal to mod of E0 by mod of H0, which is equal to 125 ohm. So we see E perpendicular B perpendicular K. E, B and K, all three are mutually perpendicular to each other, and also important thing, K will be always parallel to the pointing vector in this case. Now phase velocity will be Phi equal to omega by k, which is equal to the velocity of light c. In free phase, the electric field and the magnetic field are always in phase. And energy density of the electric field is equal to the energy density of magnetic field, and C equal to 1 by root over of mu epsilon 0 as well as E0 by V0.